Do you remember in 8th grade, Miss Bai talking to you about reflections and translations and rotations? There's actually a whole chapter in this book, way down the line. I want to say it's like chapter 9 or something, that we get into rotations and all of that in a lot more detail. But today, it's pretty basic of reminding yourself what those words mean. Let's see what chapter that is. Oh, I'm so smart. Chapter 9. Chapter 9, there's a whole chapter, like there's one section on reflections and one section on translations and one section on rotations. But just kind of reminding us that a reflection, you can think really easy about when you look in the mirror, it's a reflection. There's a line that your graph is just reflected in. So they call it the image and the pre-image, but it's kind of hard to see on here. Like our paper spreader. If you have this shape here, and then it's flipped over there, right? I think the Y, we would call that the line of reflection. That you can just take that and it's flipped over. Notice the size stays the same. So why is this section thrown in this chapter? Because this chapter is all about congruent triangles. And are those triangles still congruent? Mine doesn't really look congruent, but are those congruent triangles on there? Are there? Mine looks so weird. Mine doesn't look so long. Bigger. Yeah. That's totally a typo, don't you think?
Yeah.
That's not correct.
You just gave us a typo.
Well, the book gave it.
Never trust the picture.
Like, that should just be, like, to here, right? Or, I don't even know. It's just wrong. Let's just make sure we know what a reflection is. It's also, I just want you to know that there's directions on here that say graph the points, but they're all graphed for you already. Like, I was so confused when I printed it out. Okay, sorry. So, if a reflection is when you flip something over, what's a translation? Yeah, like you can slide it left, right, up, or down. Again, the shape hasn't changed. We call these rigid transformations because the shape hasn't changed. And so like this one, I don't know which one want to say is the pre-image, but this one, they are congruent because they're supposed to be. We're just taking it and moving it up or down so many units, and that's just a translation. So we're going to put move up, down, left, or right. And then the last one is a rotation, which is exactly what it sounds like, right? You take that and you keep it the same size, but you're rotating it around a certain point. Like in this case, it says they're the same distance from the origin, so they've taken that and rotated it. Look at you guys remembering how to do that. But yeah, I think that was rotated 90 degrees.
What if you have a square? And like they rotate it upper left to the upper right? Like then you wouldn't know if it were reflection or if it were translation or if it were rotation.
I think they would probably give you baby letters, and so the letters would be there, like if the vertices would label like A, B, C, D, then probably more than one answer would be accepted. Right? Just like on a homework quiz, that more than one answer would be accepted. I would be grading it, so. So here's part of your homework today. This is pretty easy, right? Do you have two shapes on here or one shape?
Two. It's way down. I only see one on the
Oh, here we go. I see it. Okay. Here's this one.
I see you and you see me.
Does disappear an option?
Here's an option, or here's a thing, and then this one's over here.
Oh, this one's gone.
I don't know why I can't see that. What about, okay, I can see the rest of them. Can you see the rest of them? This one's kind of hard to see. So take a second, not a second, a couple minutes, and go through and label it. Is it a reflection, a translation, or a rotation? You don't even have to do this as detailed as you did now in 8th grade right now. You don't even have to say rotated this many degrees. You can just say rotation. I told you it was a nice day today, right? I was going to skip this section, but then I thought it would be nice to do an easy lesson, right?
Agreed. Thank you.
Maybe the lighter ones means that's the second one.
Right, I think so. I don't know.
It really doesn't matter.
I mean, it doesn't matter.
Right now.
5 has 3 answers.
5 is the the one Chandler was talking about? I think so. Yeah.
Can we just write all the ones that it could
I
be?
still tell it.
I thought for number 5, I thought reflection right away.
Yeah.
Because I thought like flipping it over the y-axis, but definitely translation would also work because you could slide it, and if you took that and rotated it, would you get that shape?
Yep.
So this one could be all 3. I'm just gonna write that. But what about graph 7? What's number 1?
Reflection.
Reflection. Nope, I was just looking at it. I'm not have to say me visually is the thing I struggle with the most, like to see things like that. So I was just looking at it to make sure that it was reflection. I could do proofs like that, the visual things like this. One time I went to the eye doctor. Have you ever been to the eye doctor and they give you 2 images and they say which one's closer?
Yes.
I had to stare at those for the longest time. And my younger sister, who's 5 years younger than me, like this is when I was a teenager. I went to the eye doctor and I was like looking at it forever, and I was like, this one. And then my little sister went after me, and she was just like, boop, 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 like in an instant, could tell which one was closer. But I just don't spatially see things that easily.
Okay. So on ones like those, you want to split like all 3 or whatever. But what do we do whenever it was translated and then it was rotated?
Like
Like-
which one?
Like it's not an example up there. I'm just saying what happens whenever they.
Right now, we're not getting that complicated.
Okay.
I want to say straight.
Eventually, chapter 9, we will get a lot more detail. Right now, it's just one or the other, or like a square could be all 3 because of the square.
Translation.
The second one, I think translation.
The down is over and down.
We could
Sideways.
You can argue all 3 on those.
on number 2
No, not necessarily sideways.
Whatever, you know.
because you could
Or not reflection, but
if you rotated it 180 degrees, would that work? Or rotate it about the origin? How do you guys do that?
I don't remember. Let's just keep it simple, guys.
Keep it simple. So what about this one? Rotation?
I'm gonna
Did you say reflection on this one? Because it's the mirror image. And this one is rotation. It's supposed to be just pretty basic. But yes, it can get a lot more complicated. And if you look ahead at chapter 9, you'll look at, we get specific on how to write the reflections and the rotation and how to prove things. And we go even more, we talk about dilation. Did you guys talk about dilation last year? That does change the shape. So we don't talk about dilations right now because we're only talking about congruent shapes, where dilations can make your shape bigger or smaller. So then here's the geometry part, the other tie-in with us. What if I ask you to prove that that these are congruent shapes still, which means we could use the distance formula, but really nicely remember that if it's a horizontal line or a vertical line, you don't have to do the distance formula. Like you can just look at that and you could say that's a distance of 3, that's a distance of 3, right? We can look at this one, it's a vertical, and we can just count the vertical distance, 1, 2, 3, 4, 5, and that's 5. So we only have to do the distance formula once, or you could just do Pythagorean theorem and show that the distance for each one of those. The last section in this book that we're going to skip is called coordinate proof, and it's really just proving things on the coordinate plane, which is, we really could say this was a proof. We proved with the distance formula that those are congruent shapes, which is why we're not going to spend another day on it next week. So here's what I was talking about. Look at the directions here. It says graph each pair of triangles, but they're already graphed for us.
You know what? It looks
I was just really confused. Like I was going to white it out and then I just didn't care. So on, I was just like, whatever, I'm going to help make graph points. So like on this one, if it says identify the transformation and then verify that it's a congruent transformation. So what's the transformation on this one?
it's a reflection.
Reflection. And then we could talk about, if we were going to like prove this, we could say that AB is equal to DE, because they both equal what? They both have a length of 2? I think I'm supposed to say the measure of AB, but I don't really want to write that. And I could say that CB's length is equal to FE's length.
Keep writing. I need to write extra carrots. Sorry. I know.
I know. Well, the only reason I'm not writing congruent is we don't say like congruent to, we would say equals to.
It's just like a fourth.
So like that's why we really should say the measure of CB is equal to the measure. Isn't that what we say?
We don't know what we
We don't
say.
care either.
We're trying to congruent so much. But that's 3, right? So now you practice the distance formula, which we need to practice. Some of us do. Guess what's definitely going to be on your test? The distance formula.
If there is.
So we need to do AC and FD. Or if you don't find the distance formula.
I feel like this
Wait,
one would be
you
easy
just
with
have to do
distance.
the distance.
As long as you
You
get
can
the
do
distance.
both.
As long as you get the distance. I don't care what way you do it.
Okay.
Right? Could I do Pythagorean theorem on number 2 when I get to number 2? No. Because
Because it's so cute though.
it's not a right triangle. So you still have to know the distance formula. But on number 1, we could just say, because this is 2 and because this is 3, we could even argue, because of the Pythagorean theorem, if the legs are the same, then when you do Pythagorean theorem, the third side also has to be the same, right? You could argue that in the proof and not actually find it. Grace always likes to find ways that she doesn't have to work it out, right? Like you would write that. If you always think like that.
Got it.
So we could say 4 plus 9 equals that third side squared. So AC equals DF, which equals the square root of 13. I got the square root of 13.
You guys got it. Wait, how do you like simplify that again?
What do you mean?
You know how you can like simplify square root?
Oh, well, can you simplify a square root of 13? Is there any perfect squares in 13? No, so we can only do it if there's a perfect square in it. So if 4 goes into it, or 9 goes into it, or 16, then we can break that up. But 13, the only thing that multiplies give you 13 is 13 to 1, so you leave it like that. All right, so let's do number 2, and then that's it. And then I can give you homework, which is worksheet.
Okay. Everybody ask
Wait,
lots
that's
of
a
We're not
questions.
taking homework books. Oh my goodness. Hopefully you don't have to take home anything because you'll get it done. So I'm going to do the easy one. QS is congruent to TV, which is 2. Oh, but now I have to do a whole lot of distance formula.
Oh, darn. Guess we're gonna have to take our sweet time. About a half hour of it.
No, you want to do your homework.
And eventually
what
you
is
get to
this
assignments homework.
I'm doing RS.
Oh no, I didn't wonder the triangles, what they do.
Oh yeah, what did they do? We kind of slid it down and over.
What is it? Y2 plus Y1. No, it's
It's
Y2.
always subtracting. Just think about how you find the distance on a vertical and horizontal line. Like you count kind of like if I go from 1 to 4, I know that's a distance of 3 because 4 minus 1 is 3. So when you are doing the distance formula, you're always subtracting the x's, subtracting the y's. It doesn't matter which one you do first. Doesn't matter whether you do y2 minus y1 or y1 minus y2. It doesn't matter if you do the y's first and then the x's. But what matters is you subtract them and then you square it at the end. So you subtract the x's and square it, you subtract the y's and square it, and then you add that together. I got the square root of 5. Did you get the square root of 5 for one of those?
Yeah.
So I'm going to go ahead and check the one that should go with that, which would be UV. And here's the thing on these. It should always work. So if you don't get them to be the same, you did something wrong. This is kind of just like the proof that you're showing that they're the same. times. Isn't that fun? One plus 4 is the square root of 5. So I showed that RS is equal to UV. So then I just have RQ and UT here.
I think QR.
It's the same, right? Oh, you're trying to make me not do it?
That equals 4. Apples. Apples, oranges.
I didn't get 29. I got 5 again. Did you get 5? Did I do something wrong? Because negative 3 minus negative 2 is going to change that to plus 2. So you did negative 2 minus negative 3?
So that'd be plus 3.
So that'd be 1.
Oh, 1 not 5. My bad. Okay.
So that would be 1 squared, which is 1, plus 4, which is also the square root of 5. Which means we've also just proved that these are isosceles triangles because they have the square root of 5 as to their things. So that's another thing you could do in coordinate proof, is you could prove things by their lengths, whether they are isosceles or equilateral. And so then, what do I have left? UT? TU? Doesn't matter. I think we should get 5 again. 2 minus 3 squared plus negative 4 minus negative 2 squared, which again gives me the square root of 1 plus 4, which is the square root of 5. And I wanted us to do this again because, one, a lot of us really messed up our distance formula on the last quiz, so it doesn't hurt to do that. And another thing is, I just want to remind you that this is also a proof. We don't have statements, we don't have reasons, so we didn't write a paragraph, but we use links to show that two triangles are congruent, which is another way to prove things doing that. Questions about this? Not so bad, right? So, here's what I have for you. A one-sided worksheet.
Are you feeling okay?
Yeah.
I'm loving these worksheets. I feel like I can actually do stuff whenever it's on worksheet. Like the majority. Yeah. You see, most of the time that I get a worksheet, I do it. A lot of stuff that's out of the book.
Okay, so notice how simple this worksheet is. 1 through 4. Well, okay, 1 and 2, you just have to identify it. Number 3 says, verify its congruence, but look at number 4. That one's pretty easy to do. Number 3 has the distance formula. Number 5, also 5 and 6. You were supposed to have the graph for 5 and 6, but they did already. So you have 25 minutes, and the worst part of this is you have to do some distance formula on here. But you should be able to get this done before you leave here.
And we get rid of the
You don't need to remember. But you can verify your answers, I guess. When you work with a partner, Tim, you don't work. So.
We didn't really get yesterday.